Sorry about that. Sorry about
No,
that.
no.
I somehow just went to the breakout room and then I couldn't get back. So
No, it's okay. No problem.
yeah, it will, once it happens for a day or two, then I will figure out exactly how this is working.
I'm going to click on, hey, I can click on join breakout room. I can do that.
You can do that, right? From here.
Yeah, but look, even if you can't set the timer, don't worry about that. Just go back in when you want to close it and tell everybody I'm going to close it now.
Yeah, of course I see the red button that says close all rooms.
Yeah.
I can always do that.
Yeah, just do it manually because the timer may not be the best way to do it anyway. Something may change, the sessions may be too short, whatever. So there's no point worrying about configuring the timer. Just go back in when you want, and you can just quickly tell everybody, just say, sorry that this session is going to close. Please exchange emails or whatever you want to do to continue the discussion.
Right.
And I got to close it now. See you in the next session. That kind of thing.
Yeah. Okay. Yeah. Because I don't see any timer.
Yeah. Don't worry about whenever you can do it manually, and if you can't figure out, because sometimes those additional settings introduce other complexities that you can't really know until you do it.
Yeah.
So just do it kind of in a manual way then instead. No problem.
Like when I joined the room, I could not get back. That was strange, and there was no button for me to bring me back to the main session. So I don't know.
How did you get back? How did you get back?
I just left the meeting and then joined back in.
Oh, I see. Like by going right back out to the browser level or something.
Yeah. I just closed the meeting, not closed it for all, but just closed it for myself and then came back. Yeah.
Well, you're learning. That's how it is sometimes. You're just learning on the fly, right?
Yeah, because we don't.
But I think
do that for classes.
Everybody's pretty.
Yeah,
but everybody's pretty patient. I think it didn't take you long to get back, and I was eating noodles anyway, so it didn't matter. It's I don't know what it is. It's probably about 28 or 29 Celsius.
Oh, that's good. I mean, it's in winter. That's good.
No, it's summer right now.
Right, in New Zealand. Yeah, I was forgetting that it was New Zealand. Do you see?
Yeah, southern hemisphere. Yeah, that's one of the effects of the technology, isn't it? It makes it feel like we're all in the same place.
Yeah, that's right. You mistrack like the time and everything.
Yeah. It's kind of erasing previous levels of ways in which we've spatialized everything, with the timelines and all of that. Then that becomes irrelevant because now we're more immediate. There's no time distance.
Yeah. It's like
when we say it out loud, it sounds a little weird.
Yeah, of course. Nico, for example, where are you, Nico? I was going to say New York, Chicago, but I don't know. It's a little bit dramatic.
It's a fond of Star Wars.
Star Wars.
I just watched Blade Runner maybe 3 days ago.
Wow. That movie is a little bit strong,
heavy. It is. But it's interesting because of the
background. It's kind of, Yeah. Peter, you will let us know when do we have to behave, right?
When you have to be serious.
Like start chatting or something. Yeah, when to be serious.
I think Roy Sensei already started the recording, so a little bit too late. But...
Okay, let's behave.
Oh yeah, it is recording.
Lucy, are you dressed in gray too?
Yes, why?
Because we're all dressed in gray.
Oh, cool.
I hope this is not too late for a question, but for the session with the University of Monterrey, the 5 presentations, I just realized they are just in sequence right after each other, and there is no space between the segments. So should I introduce everybody at the same time at the beginning, or should I also jump in between the segments?
Oh, that's right. Well, whichever you feel more comfortable, but maybe could be a good idea that before each presentation, you maybe will jump and introduce our students, if that's okay with you.
Okay, understood. I was just, if your structure of the presentation was that you have that as a part, the introduction of every segment, then I would not interrupt.
Okay, no, each of them, like each 2 students, they do have their own presentation. So they're gonna be sharing the screen, each of them. So I think it's maybe students will be good if you just give like a brief moment so that Peter will introduce you. It's okay?
Yeah, it's okay.
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 Perfect. Thank you, Peter.
Yeah. Then let's start in about 5-7 minutes. So if we have other attendees, they still have time to join.
Peter. Can you hear me?
Yes, I can.
Oh, yeah, I like your background.
Thank you. It's the Tsurugajo, it's the castle of Aizwakamatsu.
I know, I lived there for 15 years.
Apologies, didn't know.
Debo, I don't have one of those, you know, whatever that is.
This one?
Yeah, yeah.
Oh, that's the just the university name card.
Oh, I see. I thought it was something official
No, no, no.
for the conference. Okay. Well, I think that that breakout room idea will allow people to continue talking if they have interests.
Yeah, yeah, that's true.
Okay, should we start?
Yeah, I guess.
Yes.
Yeah.
Okay, so welcome everybody to the third day of ETLTC 2021. My name is Peter Kudry. I will be the session chair for today for the morning session. And today's topic is smart cities and architecture. We'll have 5 presentations and the whole morning session will last about from 10:15 to 12:15 of our time here in Aizawa, Wakamatsu. First, I know we probably not all of us might be used to the whole Zoom or online session. So I would like to ask all of the participants who are not presenting to mute themselves during the presentations so we don't have any interruptions. I'm expecting there will be a Q&A session after every presentation for the last 5 or so minutes. So there will be definitely time to talk, but during the presentations, please don't forget to mute yourself. Also, I will be monitoring the chat. So if somebody from the attendees is not comfortable speaking, then they can always write in the chat. But also the chat can be used if somebody will have a question that will pop up in their mind after the presentation that the question is targeted to. Please write it in the chat, write the presentation that this question is targeted for. And then at the end, after all of the presentations, I will go through the chat if there are any questions so we can also come back. I guess that's basically everything for the introduction. So the first presentation,
question.
Yes?
Question, send the chat to you, not to the presenter.
It can be just sent to everybody or to me. It doesn't really matter.
Okay, thank you.
So the first keynote is by Professor Ana Cristina Garcia Luna Romero from the University of Monterrey in Mexico. And the topic is smart cities and architecture. So you have the word now. So if you can share your screen, please go ahead and we can begin.
Thank you very much, Peter. Let me share my screen. Okay, just a second. Okay, there we go. Just 1 minute. It is loading. So, well, thank you very much, everyone here in C and the Congress. My name, as Peter just introduced me, is Ana. You can name me Ana Cristi. I'm an architect, I'm a designer, an urbanist, I'm professor. Since the last 15 years, I've been professor and researcher. Working with the University of Monterrey in the north of Mexico. I have been in the chair of interior design department at the CRGS of the University of Monterrey. And currently, as I said, I'm researching in the field of cities. But being honest, this is the truth of who I am really, right? I'm a daughter, I'm a sister, a wife, a sister-in-law, and well, this is my family. And I think that in the last months, we have learned and redefined, or remember maybe, who we truly and really are. I always think that working with this experience of working with the University of Aizu allow us to see 2 sides of the world, which I am really I mean, I'm eager to come back to Japan and to visit you in Aizu, but I would like in this moment to introduce you a little bit, like in 3 words, what is Monterrey. Monterrey is a city in the north of Mexico. Actually, I wasn't born in Monterrey, as a lot of people who we live here in this city, we are born in Monterrey, but now I was, even since my birth, I was abroad of Mexico, and during the last years, I've lived in the north of the city, in the north of the country of Mexico, in this city named Monterrey. Monterrey means in Spanish, the city of mountains, and it is so much more than just the industrial Mexico. It is also a modern metropolis with tourists and cultural attractions that match those of the world's greatest cities, being honest. Monterrey is also influenced by its proximity with the United States, as you will, maybe some of you already know, and it is also a hotbed for art and music, and has been at the center of several cultural movements and shifts, serving a link between both countries. There are several natural wonders in the area surrounding Monterrey, but honestly, and this is, I'm being really, really honest with you, Monterrey's mountains are the most beautiful and wonderful worldwide, at least from my point of view and my experience. So we hope to have you here in a close timing, and I think you're gonna enjoy. But changing a little bit the shift, I am here today to reflect from a disciplinary approach between the different ways in which the neuroscience will change our lives and ways of living. Let's see it this way. As Peter just said, I'm talking about smart cities, but in the whole approach of the smart cities, I would like to bring over the table about neuroscience and of course, neuroarchitecture. So let's see if I get the objective done. Here, I would like to say that the mission for cities is really huge to advance to urban innovation, to make cities better, more human cities. This has launched a framework which will enable commercial and public sector organizations to use research from the field of neuroscience to develop a lot of technologies and solutions to urban challenges. It is hoped that they will boost productivity, well-being, and social inclusion. Those 2 last, I think, has been like in the top of my interest of research in the last years. So smart cities aren't just about technology, and I'm gonna say that a few times. Cities should create spaces, sustainable technologies that improve the environment in accordance with the essence, values, characteristics, and needs of the project. Therefore, offering architectural solutions that improve the productivity, the efficiency, the inspiration of collaborations between, and of course, something that is in different countries we'll say brand new, but it's not brand new. It's been over the table for the last centuries. It is the happiness, the urban happiness. So from architectural approach, and we should ask ourselves, how could the architecture improve the world? But being realistic, not romantic approach. For me, personally, as I have said, the most important thing is to create spaces with sustainable technologies that improve the environment according to the essence, as I said, the values and the needs of the city itself. So before I got into full detail about what I believe in related to neuroscience, that it will change our lives, I will tell you a story that I think is already quite common, or maybe you have heard, but some years ago, it was very rare to hear this phrase of Churchill that says, we mold the buildings that later mold us back. So when the Germans bombed much of England, one of the things that they damaged was the House of the Commons in London. And Winston and Churchill wanted to remodel or rebuild, whichever, but nevertheless, since it was really, really expensive, the construction, Churchill wanted or bring to approach to the parliament to get the money and convince them, despite anything was on this face, us back. So what he said was this phrase to the parliament. He said, you know, we mold the things that later mold us back. And this is something that I think that it's really, really important and to know and to reflect and to, I will say, to that students, citizens learn. You know, it's not only about aesthetics, it is actually the way we are molding ourselves in the cities. So this was a long time ago, but I think it's something that we can still reflect on. So if we now talk about the concept of neuroscience in particular, I believe that neuroscience in smart cities is going to transform absolutely everything we know, because the university talks to students about a deep knowledge of who we are and how we function, and maybe give us some light, you know, about how the neuroscience is related, especially in some countries like the United States. Speaking about America, you know, this is not a weird or unique concept. It is also something that has been introduced into the bachelor's or, you know, all degrees, but we have still to relate how we process information. How do we perceive information? How do we translate information between human beings, the physical space, but also with the technologies, because technologies, they're turning to be some way we relate and to the human being, you know. So cognition in here works correlated between the human being and the technology. In the last 2 decades, the society has generated more knowledge that had been generated in the previous 2,000 years. And this is when an analogy can be made related to the neuroscience. Because the first line in here I would like to approach and highlight will be the embodied cognition. The concept of embodied cognition is a well-proven theory that argues that the human being does not think with the brain only. We think with the space, you know, and there is a stream of explanations. If you grab, as an example, if you grab a pen and after a few minutes of using the pen, your brain begins to assume that the pen is an extension of our body. So this is why we are relating also architecture with the cognition and architecture with the embodied cognition. So going back into the example of the pen, you begin in that case, in that moment, to think in a different way because you have a pen, right? And you can have different things maybe, but you can access different knowledge because you have the pen, as I was saying, and sorry, it's because in here, move my computer. So in here, what I'm trying to go and the point I'm trying to head is that because when we start to question architecture, not only as it could be at some point related to aesthetics and with the technologies, therefore you can start to question if architecture is really cognition and if architecture is really related into the cognition process, or if it is part of a much more complex system that we have talked about little in architecture. And of course, relating architecture and technologies when we talk about design, of course. So related to our ETLTC 2021 approach, we can emphasize in here how technologies can work in a collaborative way with architecture to create smart cities with the ability to be responsive to the human being. That I think this is in here something that I really, you know, value from the approach of Devo, that he has always seen this, you know, open, wide approach for the smart cities where, and I go back to the beginning of my keynote, where interdisciplinary approaches has to be done and has to be worked in everything related to smart cities. So on the other hand, we should also question related to the awareness of the space. This concept has been related to some neurons in the brain that are responsible for literally our GPS measured distance, because it measures the limit and it's in this direction the space cells we can maybe have in our brain and in our system. So the awareness of the space And these space cells are found in the hippocampus, you know, in our hippocampus, in our head, which is one of the parts of the last areas where an experience looks complete before it becomes a memory. And from there, it is stored in the rest of the brain in different parts. So related to this, I truly suggest the book of Johnny Palasma called The Eyes of the Skin, because it is a book. In this book, he, with this, you know, title, The Eyes of the Skin. So this is, it is a really poetic speak from a logical perspective regarding the importance of the skin and the perception. And this is correlated to the architectural phenomena, as I said, as the poetic of the space. So the next line of thought in here is the neuroplasticity. Recently has been discovered two terms of neuroplasticity and neurogenesis. Neuroplasticity is the capacity that the brain has all the time to be changing. I mean, this is really beautiful, right? There's nothing on the planet that changes so fast and really as much as our brain. So our brain responds to those changes, to those, you know, evolutions, first, to a great extent, to the environment. And second, the discovery that is closely linked to the neuroplasticity, which could not work if there were no neurogenesis, you know? So change is something to what we are related, that is part of ourselves. But here, of course, since a professional approach, it is not only something that has to be abroad from, you know, shrinks or psychologists or even doctors. It is something that has to be re-questioned and reflected from an interdisciplinary approach, of course, but related to technologies and into architecture. Since, you know, I think we are changing in the world and we truly need to re-question the way we are creating these smart cities. So today we are still dragging it out because it has been thousands of years of evolution against any possible or 100 and 200, and you know, architecture as we know it in society has to be related to aesthetics. I think something in here, and the students who are here with us today, they change their shifts and they do not only have study architecture because of the aesthetics, also because something, the perception and the relationship between architecture, space, and everything I've been talking in this keynote, you know, something that is in our brain and the way our brain related into the space. So one of the great challenges, possibly the most complex challenge of neuroarchitecture, is that it should be a bridge between two worlds that do not talk about the world of architecture. So the bridge has to be also well known because of architecture. And in here, specializing in these issues of neuroscience applied to design is somehow to make this bridge between these two worlds that rarely connect. And it's a complex challenge because even the vocabulary is different. And this in addition to seeing the world completely different, or at least in a different way. So beauty, neuroscience, and architecture understand how architectural and interior design impacts humans, which is something that has to be, you know, like kind of reflected when we are designing smart cities. So in here, it changes in our vision of the relationship of the spaces and the objects with the human being. Not only reason why experience exists is to create memory. And I believe that what we are going to start some way learning of the neuroscience subjects is that we are going to start taking much more seriously the profession either of interior design or architectural or architecture and its relationship with technologies, which in here, in the approach we give here into the ETLTC, I think those are great news because that means that we have to work together. So, and why? Maybe you will say, but why is going to be disconnected? Well, it's going to be connected because the impact on those of us who are designing the space is so permanent in the human being that the career really needs to shift. You know, the program of bachelors really need to shift and go deeper. And of course, I'm here thinking about the bachelors and the masters and the PhD. But in here, what I really want you to reflect and to think about it is that professionals from both parts need to work and, you know, to see it on the creation of these smart cities. So let me just one question in here is that we do not design architecture. In reality, what architects has to do nowadays is to hack brains and to hack the ways of living for having smart cities. So the future of architecture in here, I would like to just give a quick points before I close the keynote and before our students are going to start presenting one of our exercises of last semester, is that we are approaching materials and we are approaching the environment for smart cities with the name of material ecology, which is more a skin to growing than the building itself. So when we enter architectural school and we study how to design and build, or even a simple product like a chair or something, a table, something of design, industrial design, we're used to defining or design that product in 3 dimensions, the X, the Y, and the Z, you know, like the physical space. But nature obviously operates in a matrix of dimensions that far exceeds these 3 dimensions of the space, you know, the X, the Y, and the Z. So by these dimensions can include forces such as load, temperature, heat flux, variations, humidity. In here, with the pandemic, I think we have learned that also viral forces, microbial forces, and those are forces that usually do not enter in the design process. So for smart cities, we do need to enter those new, you know, like data, and that architecture and all the computational tools and technologies, they respond to have cities, smart cities, you know, like the real name of the smart cities, but creating to human beings. So nowadays in architectural designs, there is a dimensional mismatch between the products and the buildings that we are designing and between the forces that are informing or shaping those buildings. So in this exercise that our students from UDEM are going to present, they are a clear example of how we are trying to change this approach to architecture. And of course, in America, especially in Mexico, trying to create smart cities, you know, but for the country to where we are working on. So in here, what kind of tools could we invent to make materials that gradually vary their properties and allow us to create multifunctional objects? This is something that maybe we could reflect not only from a technological approach, not only from an architectural approach, better yet from an interdisciplinary approach where we can work together. In this case, with our students, we work with building skins that they act both as barriers that are in a structural, you know, approach, but also they can filter air, heat, control temperature, or regulating some kind of those new forces, as I was saying. So the goal, of course, it is that in the natural world, however, you find material systems that vary their properties gradually from stiff to soft, maybe from opaque to transparent, from strong to very strong, or many other options. But we are able nowadays to invent and fabricate materials that vary their properties gradually and allow us to create multifunctional objects. For example, building skins that act both as barriers and as filters. They can filter air, heat, as I said, control temperature, any others, depending on where we are on the world. So this is our goal here in UDEM, to work with our senior students and how to create systems and which technologies must we create invent or redefine that enables us to generate these multifunctional systems, right? So we'll start with nature design, nature-inspired design, and we'll end, pretty sure, with design inspired by nature, a place where we actually designing that nature. So somehow, some way, we're gonna be living, or we're gonna be working with that material ecology, right? So also computational processes and algorithms, that are informed and inspired by the natural world, as I think you are here, the professionals on that subject. But therefore we move from nature inspired to nature informed, using materials we find in the natural environment to design nature itself, using synthetical engineering, maybe with DNA, or creating types of biological materials, smart skins, or any other where between man-made and nature growth is obliterated. So in the following UDEM students presentation, they'll be able to present an architectural project designed for a Montessori school in Mexico, in our city, which is Monterrey, as I said in the beginning, and considering all these concepts as framework. Of course, each of the different teams of students, because they were working 2 per 2, they start from the same point, but their processes and their results are way different. You're gonna see it. And in Mexico, as many other countries in development, architecture is really evolving for an interdisciplinary approach. And I would like to highlight this in this keynote as one of the main messages from myself. So I think that from that interdisciplinary approach, that will lead us into the really human smart cities. Okay, so in here, some brief examples, some beyond morphology, beyond aesthetics, but I think that technology and aesthetics, which we will say morphology and architecture, has to work together. There is no other option. And I think during this, well, almost 1 year of the pandemic, the COVID, we are learning that we really have to move quicker, and smarter, not only for smart cities, but for a better human, life for all of us, no matter where we are. So it's been a pleasure. Thank you for the University of ISU. Thank you so much, Roy. And well, thank you all for your attention. And please do not hesitate to contact me for anything I could support or collaborate. It will be a pleasure. Thank you very much.
Thank you, Ana, for your presentation. Are there any questions from anybody?
Yeah, I have a question for Ana.
Yes, of course.
So, yeah, thank you, Christina. That was a great talk. You brought about a very interesting concept of neurogenesis, and as far as I have checked, neurogenesis in architecture is a pretty new concept. It hasn't really been explored as much. It's probably very new, evolving at this time. So one of the things from my perspective, this semester I taught a class on smart cities, but it was exclusively on smart toilets. So in intelligent toilets that can understand when you're approaching.
Okay.
It will follow instructions, how much water to be filled up in the toilet, in the bathroom, motion sensors and all those kinds of things. Because we are a computer science university, so all these things are exciting to the students. So that brings me back to a question of when you're talking about neurogenesis, you're also talking about creating affordances for humans, so that humans you're making lives easier for the humans, right?
Yeah.
So, but using IoT to create affordances, do you consider it to be a neurogenesis, embryonic development that is happening in humans? Do you consider that? Do you consider using such a technology to make life easier is actually neurogenesis?
Well, in Europe, particularly in Spain, at least from the experience I've worked with the Fundación 11, they will say yes. From the approach with Canada and the United States, especially in Canada, that in the north of the United States and in Canada, they are really, really, at least also from my perspective and experience with working with them, two approaches. One is they are really interested in the urban happiness, and also about this neuroarchitecture, neurodesign or neuroscience, as it is named in there. They are saying that human beings, with time, we are having more gadgets, like inside of us, and that helps us generating, getting more data about our systems, the way our body works on, and we kind of relate in that technology. But for them, neuroscience it is to say, like in these words, the possibility in the link between the human being and the space, and the significance we give to the space, either if it's, like a place or an object, as I said with the pen, how that generates more neurons in our brain. And of course, the impact that does it has. So this is why they are kind of relating neuroscience with urban happiness, how happy is someone, with anybody, any citizen, with the life, the way of life, the products, or the way we are relating with the physical environment. And when I say physical environment, I mean products, but especially space. That space, of course, is where I am more interested and working on relating. So, and I will say again about Fundación 11 in Spain. They work with people with different capacities, people that maybe has a physical discapacity or something. So they are trying to find, for smart cities, like a way of opportunity where human beings, if you either have or do not have any capacity, with technology in your body, you're gonna get that. You're gonna, I don't know, maybe when we are older, you're gonna try to, with the go after any damage that you can have in your heart or anything. So that is something particular with technology. And yes, it is something that it's related into the way we are, the way our body works, and how can we get data from that. I'm not sure if I got to answer you, Gabo.
Yeah, understood.
Could I make a quick comment? Just, I think in your approach, Anna, you're taking a phenomenological approach. Is that right, partly?
Yeah, that's right.
And so when you talk about technologies as being extensions of the human, so I understand that, and I think I do, and that's like McLuhan, but it's also like Bernard Stiegler. And so then we start to conceive of the world as, because we are human, and we see the world from our perspective as we are, and therefore all the things that we use to describe it, including language and all the things we build and create, are extensions of ourselves. And so, I think that this is, as a contrast to a purely aesthetic approach to architecture, this is much more deeply consistent with modern philosophy. Actually, it's starting to, and some of these different perspectives, like it's amazing to hear that this neuroscience approach and architecture and philosophy are starting to converge on similar understandings of how to design a more reciprocally aware kind of environment where things aren't just built from isolated idiosyncratic positions, that there's actually an attempt to design in a kind of confluence of everything. So, that's quite amazing, actually. And I didn't expect to hear that during this presentation. I didn't know what I would hear, but I'm very pleased to hear this.
Thank you, John. Thank you very much. Actually, I think it is a big opportunity, at least from, again, America's perspective. We are working in the North countries of America in this kind of neuroscience, you know, and the way it is related with the environment, because we are not only approaching environment, natural environment, we are also approaching physical environment, because of course, big cities, you know, all these processes or social urban processes or phenomena that has to be re-questioned, especially for the countries in the center or south of America, that we are in that point of, in that process for development. So I think maybe it's a big shot for those countries. One of those is Mexico, but we have such a big, you know, road to go through. I think it's worldwide. And of course, in the neurogenesis, it is related to the process by which the new neurons can be generated from stem cells and progenitor cells. So this is way not easy. For example, how do we architects work with that? Sometimes it's like, for example, in our building schemes, we try to work with, I don't know, creating or cultivating some cells, and then the building is gonna be response, or it is about, I think, and something that maybe Hiram, that with whom in the University of Monterrey we work really close, it's about the interdisciplinary approach. And I think that is something that we have to highlight. You know, that is something also that I really enjoy in the ideology of Devo, of Roy, that interdisciplinary approach, you know, it doesn't matter what the book says, because that approach, the interdisciplinary approach, is the new approach, you know. And we have to question ourselves about that, starting with biomedics, with engineers, with technologies, with architecture, interior designs, with doctors. In the last 2 years, I've been on a research about cities and you know, the human body as a medical approach. And I have learned, as I said in the keynote, the vocabulary is way different between the architect, who am I, and the doctor who's speaking so many terms that I just got to look into the, you know, to him and said, oh my God, I have no idea that my fingers had so many names, you know, so many things, but we have to understand. And from an urbanistic approach, the cities, and this is about the embodied cognition, which I talk in my keynote, the cities, everything, the spaces where we live reflected ourselves, you know, for better or worse, but it does. So we have to give a step back to give a really big step, you know, for better cities. It's not only about the smart of a city, it's about the smart human cities, you know, we're urged to create and to promote.
It's about the empathy of the city.
Of course, of course. That's the difference. If you live for some days in Tokyo and then you come and to live for some days in Mexico City, you will tell me about that, you know, and I will be glad to hear, you know, comments. So it's about that. It's about that. And then you go to New York City, it's going to be crazy for you, you know, so we need really smart human cities.
Yes, thank you very much. I also had a question, but I think unfortunately we should move forward, and then I can probably ask at the end. So our next presenters will be Lucy Elisa Mendoza Rios, Andres Escamilla Mejia, and Ana Cristina Garcia Luna Romero again about the Montessori project. So please share your screen, and thank you for the following presentation.
Hello, I'm Lucy, and I'm gonna present the Montessori project. Just let me share my screen. Can you see my screen?
Yes.
Yes, okay. Okay. Well, good evening and good morning. My name is Lucy Mendoza. I am a BA architecture student from Universidad de Monterrey in Monterrey, Mexico. Today I will present the Montessori project. Here is a picture of me and some information about myself. Well, to start, the index shows the topics that I will be talking about throughout the presentation, and it includes the character of a building, the Montessori method. I will land this concept into my architectural design. Then I will explain the Montessori project at the city of San Pedro Garza Garcia in Nuevo León, Mexico. Then I will talk about the intelligent buildings and the architectural skin, some renders, and finally some conclusions about the topic. Well, first of all, I will talk about the character of a building. In architecture, every building is different, and in order to comprehend buildings, one should start analyzing the different characters or components that will fill them. By understanding buildings, we understand that every building is made for a reason and that they are unique, and each one has their own spirit, which associates its character with the architectural design. Now, let's talk about the Montessori method. This methodology was created in 1912 by Dr. Maria Montessori, who was an educator and a pedagogue and created different methods that improved the learning and education of children with disabilities. Her main objective was to create pleasant and suitable environments for a better development that could generate intellectual and social skills. First, she made a profound analysis and then got to the point that there were 4 periods called the development plans, according to age that children go from infancy to adulthood. And here I made a quotation that she said for a better understanding on her study. Now, these 4 development plans were the infancy, which was the first one, that comes from the stage of birth until the child is 6 years old. And it is characterized by the absorbent mind of the child. And here is when the child absorbs every aspect from the environment around him, just like sponges. The second one is a childhood that comes from 6 to 12 years old. And here's when we talk about the reasoning mind, in which a desire of exploring the world exists and the personality begins. The third part is the adolescence, that's from the 12 to 18 years old. And it talks about the humanistic mind, when the child starts to understand humanity and it starts making contributions to society. And the last one is the maturity, that's from the 18 to 24 years old. And it's when we're already in adulthood with the desire to explore and make social relations. This model seeks to offer children free opportunities with the use of universal design. Its environment is characterized as a spacious, orderly, and aesthetic place to emphasize the good educational development of the children. Here's when we start talking about the furniture and the designs, because its aim is to purpose comfortable spaces and generate a sense of belonging to users. Independent freedom is one of the main goals of the model, because it allows children to act and think for themselves, developing confidence and self-discipline. Now, all these concepts go around the Montessori classrooms because, of course, they are the spaces in which the students are most of the time. They are designed as a favorable environment, which are easy for children to adapt. The colors, the materials, and the texture are studied to arrive to the final design. These classrooms are specially designed to promote the learning process with positive attitudes. Because of the past studies, the Montessori classrooms are subdivided according to the evolutionary needs of the children. With these divisions, children can freely work individually or in teams, which helps them with their self-discipline. Now, let's land these concepts into my architectural design. The Montessori educational model focuses on the needs to create habitable and creative spaces for my project proposal. The main concept that I included for my architectural design is the architectural design, and its main objective is to mix different solutions in order to create a Montessori educational system. So the concept is based on 4 components, which are the neuroarchitecture, the universal design, create community, and sustainability. And my objective is that with the mixture of these elements, the architectural design will be able to create accessible halls and promote the education. Now here's a more detailed diagram of the architectural design concept and the mixture of these 4 components that I mentioned before. Now about my project proposal, the Montessori project at the city of San Pedro Garza Garcia in Nuevo León, Mexico. First of all, I started making a complete analysis of the population of the city to have a more panoramic view about where I could propose the Montessori project. And finally, I got to limitate the study area at the southwest part of the municipality, in which schools are highly conglomerated, and with the implementation of the project, I could complement the educational model according to Dr. Maria Montessori. Here's a more detailed view of the location of the project, its extrinsic characteristics, the roads, and the topography of the project, which was a main point for the architectural design. And finally, some data about the area. Now, according to these studies, there is a need to improve education, and my project fundamentation goes much further than just physical environment. My solution to the problem is to incorporate emotions and study themes of narrow architecture to improve the well-being and reduce stress, anxiety, or depression of students. This will include diversity in interior and exterior spaces to make the best project possible. Here's a mood board of some ideas I had for the project. Now, here are some diagrams that represent the volumetric process of the design. First, I incorporated 4 platforms as a result of the land's topography. Then, a road axis was incorporated with the first volumes of the school. On the third step, the next levels were incorporated, and on the final steps, the sport areas were located. Here you can see the architecture program with its different areas, their location, and their area. Now, here you can see an isometric diagram that represents the different levels of the project with the pedestrian route and the recreational spaces of the project. About the blueprint of the Montessori project, we start with the architectural plans in level 1 with the sport areas. Then level 2 with the classrooms, library, cafeteria, and central patio. Level 3 with the main axis, offices, newspaper library, and classrooms. Level 4 with the teacher rooms, the auditorium, newspaper library, and finally the level 5 with just the auditorium and the newspaper library. Here you can see the complete plan set. Section A, Section B, the north and south elevation, and finally the west and east elevation. About its structure, it was decided to implement wood as the main structural material to promote the consideration of environmental and sustainable factors. Besides that, it is also a key element for the generation of optimal spaces to fulfill the concept of narrow architecture. This structure consists of frames made of wood that are supported by metal elements. This is repeated throughout the project, generating spaces for a free facade and include the architectural skin. Now, talking about it, we'll talk about intelligent buildings and the architectural skin. First of all, what is an intelligent building? Well, this concept is defined as a responsive architecture. It includes conditions such as energy, technology, safety, cost effectiveness, and environmental conditions that emphasizes sustainable design. The architectural skin makes a project intelligent and makes it even more technological. Thanks to this technology, a building can be adapted to its environment and provide optimal spaces for users. For this, I studied a case of a cafe restaurant in Amsterdam that uses a type of architectural skin in its glazed facade. It generates a modern and a pure box, allowing users to move these windows to create a better indoor environment. These windows are demotorized, so people need to move them by themselves. This helped me to get the ideas for the Montessori project proposal and innovate this functionality. Now, to innovate the architectural skin, I decided to make it a sun-responsive facade. And for that, I made a sunlight analysis that covered from 8 a.m. to 6 p.m., which are the normal scholar hours, and finally got to the point of applying the architectural skin to the Montessori project. The design is based on windows that bend themselves automatically in response of the sun. It is a motorized system that activates when the sun touches the facade. When the mechanism is folded, a type of parasol is created for the generation of shadows and a connection to the exterior. This facade also includes the sage glass panels, which are an electrochromic glasses that changes color depending on the ultraviolet radiation of the sun. This facade helps in topics such as intelligence, technology, and sustainability. Here is a more detailed illustration of the parts of the architectural skin. And here is the sage glass function. Finally, some renders of the Montessori project and the intelligent building. And here are some 360 panoramic views, which I have over here. This is an exterior view from the project. This is the central hall of the project. This is an interior view. This is the administration of the school. And a final exterior view. Now, finally, to conclude, the Montessori method makes life easier for everyone, and using it as a base topic, combining it with a profound analysis, people can apply architectural designs to other projects to generate better environments. Technology, sustainability, and sensorial elements are factors that can always be taken into consideration when talking about innovative architecture. Thank you.
Thank you for a lovely presentation. It's truly amazing to see that even the psychology of the students was considered during the design. I would just have a very small request. Is it possible to share the links for the visualizations and the renders in the chat so we can bookmark it in our own browsers?
Yeah, sure.
Lovely. Thank you. Thank you very much.
Just have a quick question. What is the
Yes.
sage glass function? You mentioned somewhere, sage glass function.
Yes, I have a video about that. Maybe, I don't know if I can show it. It's 1 minute long.
Yeah, sure. I think.
Okay, hold on.
Yeah, we still have time, so.
Okay.
Oh, wonderful.
Yes.
If I may, a question about the Sage class. Is the Sage class programmable or is it fully automatic?
Well, the part that I investigated was that it was automatic because of the response that it has with the sun and with the pressures on the glass. So it kind of, I mean, it acts by itself. So this is why we implemented it on the architectural skin, so that when it's closed, it can automatically respond to the climate, the sun, and everything on the outside, and create a better interior on the inside. So what I investigated, it was fully automatically movement and everything. It was just automatic.
Thank you.
I'll send the links of the panoramics.
Okay.
Okay.
Are there any other questions?
May I ask a question?
Sure.
So I'm Evgeny Pishkin from the University of Aizu. So thank you very much for a very impressive talk and very impressive project. The question is, what do you think about, let's say, more practical things like implementability of this project? So how would it cost? And if we go to the implementation, could it be that we probably will need to reject some kind of very innovative technologies because of their very high prices, as I may guess?
Yes, well, when we started designing this project, we started thinking about the price, and actually it is a very interesting question, because maybe we were thinking like out loud, and maybe it would be really expensive, and that was one of the things that we I mean, it was one of the things that we were really afraid of when we were designing this project, actually. And we really didn't investigate it about the prices of what we implemented. So we know it would be expensive, but maybe we could adapt this design into prices. So maybe, for example, if the Sage glass is really expensive, then maybe we could implement another glass which is not so expensive, but still implementing the architectural design, for example. So maybe we could take off some elements that are really expensive and keep some elements that are like the base elements for this project to function, so that it could adapt for any price or desires of the project. So I think it would be expensive with this motorized facade and the materials that it include, but it doesn't mean that we could adapt these materials or options, diversity of elements, that we could play with them so that we could adapt it to more or less prices.
Thank you very much. But anyway, that's a very impressive talk with creating a design which is very responsive, which is a kind of creating interactive design, responding to the major usage scenarios and quite probably unusual usage scenarios. Just I'm interested in architecture as a kind of side activity, so just not my major. So that I like such designs very much. Thank you very much.
Thank you very much.
Thank you very much again. And I think we should move forward to our next presentation. So the next presenters will be Maria Teresa Martinez Lozano, Miriam Janet Duarte, Ibarra, and again, Ana Cristina Garcia Luna Romero. And they will be talking about topic how using smart buildings technology can improve indoor environmental quality in educational buildings. So I'm guessing it will be very much related to our previous talker. So please share your screen and begin whenever you are ready.
Yes, thank you very much. Well, good morning. My name is Miriam Duarte.
And my name is Maria Teresa Martinez.
And as we already talked about, we are going to present how using smart buildings technology can improve indoor environmental quality in educational buildings. So we are going to explain how an educational building must integrate smart building strategies to ensure indoor environmental quality, and how thermal, acoustic, visual comfort, and indoor air quality are to be considered. Otherwise, the buildings could develop the sick building syndrome, which we will explain next.
And also we are going to talk about that the smart buildings solve this potential problem by providing a highly efficient living ambience that includes safety, comfort, and a good quality of living, learning, working experience. And that helps the users achieve their best possible performance. And finally, we are going to talk about a case study of an architecture project for an elementary and junior high school academic campus in the state of Nuevo León, Mexico.
And well, these are some of the topics we will be talking about. And first, we are going to explain the problem with contemporary buildings. So nowadays, there is a trend in many places around the world of building constructions with facades designed entirely of glazed corner walls. However, these designs present a serious energetic problem in cities with a Mediterranean climate. These glass buildings consume more energy than others because in summer there is a huge demand for air conditioning, while in winter, on the coldest days, there is a loss of heat that has to be compensated. Over time, changes in the designs of buildings meant to improve energy efficiency have made homes and offices more and more hermetic. Therefore, these types of buildings, which are called sick buildings, have deficiencies in their indoor generated climate affecting people's health, causing symptoms such as headaches, irritation, and feeling of fatigue, among others. Also, technological advances in construction have led to the use of synthetic materials that can easily accumulate pollutants such as volatile compounds coming from different sources, such as the heating systems, paints and varnishes in furniture, construction materials, or cleaning supplies. So it is necessary to create building designs that are well integrated to the surrounding environment and climate in order to improve its energy performance. Now, why should we opt for an environmental design? Environmental design is not a new concept, but has been applied since the Industrial Revolution when engineers were able to construct buildings in almost any climate around the world. However, to achieve this, high-grade energy has been used to address problems caused by weather conditions and problems resulting from building design. Therefore, it is necessary to reduce the dependency of buildings on fossil fuels to generate this huge amount of energy, but at the same time, achieve the environmental quality that provides comfort to users inside the building. We must take advantage of the natural sources of energy, lighting, and ventilation, such as the sun and the winds. These are some of the aspects we must consider. First, the thermal comfort, which includes thermal parameters of the environment that influence the human body. One of the first elements to provide thermal comfort is to create an envelope in the building that acts as a filter between the outdoor climate and the indoor climate. This way, an interior microclimate is established and stabilized, reducing the use of energy-consuming mechanical systems. Then acoustic quality depends on how well sound sources are controlled. To achieve acoustic comfort, you must first make a good design based on a complete site analysis. However, in the end, the acoustic performance is in the hand of the finishes. In order to obtain a quality acoustic space, special care must be taken when selecting technologically advanced materials in order to moderate noise levels. Now, visual comfort. This comfort has to do with the correct balance of natural lighting with artificial lighting. Natural light should always be prioritized in any design since it is the most comfortable lighting for human eyes as they adapt to it naturally. Taking advantage of natural lighting has a positive impact on our health and well-being, increasing our lucidity and productivity during the day, which are necessary factors in an optimal educational system. It also generates significant energy savings, decreasing the excessive use of artificial light.
The buildings that best respond to an environmental design are the smart buildings. Their goal is to provide greater efficiency and control in the building's operations, responding to a better quality of life to users inside the buildings. Also, the smart buildings have systems that are controlled automatically through the use of sensors to adapt to the need of the users. The adaptability is an essential characteristic of smart buildings. It is the ability to use internal and external information from various sources to prepare the building for specific events before they occur. But there are four other factors that we can consider as smart buildings. These are the intelligence, the operations, the materials, and the design. A positive impact of smart buildings on society and architecture is that they have bring new possibilities about architectural design solutions. This can be done through the design of passive and active strategies that brings the best comfort to the user with the least possible use of energy. And well, one of the ideas that has changed in the technological advances is the concept of the facade that becomes envelope that protects the exterior of a building from the interior, also known as the architectural skin. The design of the architectural skin should have a sustainable objective, using materials and construction details that allows the transfer of energy through the envelope of the building. Also, is an essential component to solve the problems of responsive architecture. Intelligence can be implemented in the architectural skin as a solution for the environmental elements that affect the building. And the advanced integrated facades are responsive elements of buildings that control the energy that flows from the outside to the inside. This facade is an interesting application of advanced solutions for buildings envelopes, which have been incorporated into research activities and industrial developments. And well, then we are going to talk about the case study of Montessori Institute. The Montessori project is an educational complex for young students learning through the Montessori teaching method. This education method differs from the traditional model by letting children choose freely what to focus on during their learning experience. The objective of this project is to develop an architectural proposal that introduces an innovative solutions to fulfill the needs of a Montessori method-based school, adapt to the present conditions and those of the future generations for a basic education campus in the metropolitan area of Monterrey, Nuevo León, Mexico. A school should be an ideal space for children to learn and develop their cognitive, motor, and verbal skills, as well as an interest in discovering the world around them.
And the main concept on which we based our design includes these three different aspects: the responsive skin, universal accessibility, and landscaping. So the educational compound is made up of three main areas. First, the administrative area with management office, admissions, a teacher training center, and meeting rooms. Second, academic spaces including classrooms, a library, music, art, dance, and computer labs and rooms, as well as a cafeteria and the theater.
This is divided in the elementary building, the building childhoods buildings, and the upper elementary buildings. And finally, we have the sports area that includes the gym, basketball, soccer, and volleyball courts, as well as the recreation space for parents. Then this is the second level of the elementary building and the second level of the gym.
Yes, and our project is developed north of the municipality of San Pedro Garza Garcia in Nuevo León, Mexico, which presents an extreme dry and semi-dry climate. But considering these extreme climatic conditions, which are very variable, it was sought to implement solar capture strategies for heat and lighting, the use of winds, the collection of rainwater to protect the building from the environment, generating comfort and indoor environmental quality.
Some of the strategies to generate indoor environmental quality and that we use in this project are first the ramp air system. And this is a construction system that we applied in this project, and this consists of filling a formwork with layers of soil, compacting each of one of them with a chamber until the desired height of the wall is reached. The ramp earth is an excellent material that helps to maintain a stable temperature inside the buildings throughout the year. It can store cold and heat, and it has a good resistance against wear and tear. As well, the ramp earth wall provides a characteristic aesthetic that generates in users a sense of appreciation towards the material of the earth and the natural environment. It is used on exterior walls of the buildings, and the facade includes large windows to take advantage of natural light. The second is the native vegetation. To prevent the solar incidence on the most vulnerable facades, native vegetation is used as a protection. The predominant presence of trees and shrubs of different and varied dimensions will lower the temperature of the place, generating a microclimate. So the vegetation is used as a passive cooling strategy since it allows to manipulate the winds, taking advantage of the volumetric shape of the context. And this integration of native vegetation in the project helps to deal with the need for humid air to control the evaporation.
The third strategy is a responsive skin that protects the building, which is made up of a self-supporting structure in the shape of two intersecting chamfered domes of approximately 150 meters in diameter, which encompass the entire project buildings. The structure is made up of modules in the form of trapezoidal prisms, and because these are adapted to the curved shape of the domes, they have very varied measurements. These models were generated parametrically, so they are more open in the upper part, depending on the entry of the prevailing winds in this territory. That is why the largest models are located in the southeast part of the structure. A responsive skin is made up of materials that respond to changing environmental conditions. So in the upper part of each module, an FT element, which reacts to temperature variations by rotating, is used, allowing or preventing the passage of ultraviolet rays through the structure. The responsive architectural skin behaves as an active bioclimatic strategy that acts according to external environmental circumstances to maintain an ideal thermal condition in the interior spaces of the building without using any additional energy system. With the help of the responsive skin, it is possible to control the speed of the airflow through natural cross ventilation, which generates a cool environment in each of the buildings. Solar radiation is controlled by regulating the temperature throughout the buildings with the help of the architectural skin provided by the modules. Now in MODIX. In MODIX, as building automation is an active control system which allows the building to function intelligently. Its system allows an efficient management of energy consumption, security, accessibility, and comfort of the building. The project has automated systems that respond efficiently to the user's needs. It has a hybrid ventilation system, energy saver elements such as dimmers, motion sensors, and temperature regulators, high security features that authenticate the identity of visitors, and intelligent automated fire protection systems.
These are some of the building's elevations where we can appreciate the different heights and the relation of the responsive skin with the whole project. These are some interior perspectives, and first we have one of the elementary building's classrooms.
Then this is the arts classroom on the second level where we can see the connection with the exterior through the window. And this is a computers lab, which is located also in the elementary building with the variable furniture for the different interactions of the children.
This is the central module, which is the center of the whole campus and provides connections between all the buildings. On these exterior perspectives, we can appreciate the predominance of nature with the native vegetation.
Also, the exterior paths, connections between the buildings, some exterior areas like the playgrounds, and the relation of the responsive skin with the whole complex, which provides an experience where you can interact with the exteriors while being in the interior of the campus.
Some of the conclusions we reached through our investigation and the design of our project are that it is important to an optimal indoor environment quality in educational building and rely on the fact that it has a positive impact on user productivity.
Also, the implementation of the ramped earth wall technique is ideal in the construction of educational buildings in this region of Nuevo León in northeastern Mexico.
The usage of native trees and vegetation around the property generate a sense of belonging in the users, making them feel connected with nature.
Also, the responsive architectural scheme serves as an environmentally oriented technology.
Also, innotics must adapt to the current rhythm of life of children, teachers, and collaborators in the different spaces of new projects.
So this project becomes a meeting point between technology, education, architecture, and nature. Thank you very much for your time. We appreciate very much your attention, and we invite you to visit our project in this 360 panoramic view. Thank you very much.
Thank you very much.
Thank you for a great presentation. Does anybody have a question?
Yeah, I might ask a few questions, but before I do, I'd just like to congratulate you on some excellent work trying to integrate all the different factors that I know you appreciate are involved in evaluating and maintaining good indoor environmental quality. And I think that you've actually said all the right things about that. And I also want to know about how deeply you've thought about meeting standards, because there are standards in all these areas that construction efforts will try to meet so that they can get government credits and so forth. And I just wonder if you've looked at those standards and whether your particular proposals that you've made are doing the construction companies any favors or not. And by any favors means, have you asked them to do things that actually cost them too much money and don't gain them the financial benefits that they would hope to gain by being green? Maybe you're familiar with this idea of greenwash. They just want to be able to say the right things, whether they are actually doing what needs to be done to really maintain indoor environmental quality. So can you speak to that a little bit, since you didn't talk about that aspect? It's a very practical matter. How do you meet the standards in order to gain from more than just the lip service? the greenwash, as it's called in the field?
Yes, well, what I can say about that is that, well, for example, the rammed earth technique is a little costly because the process is very like complex, complicated, and not many people know how to do it. But we wanted to use it because we think it's like the benefits that it brings outrun the cost that it may have. And thinking like on a long term, the implementation of all these techniques can lead to greater economic benefits. So yes, it is a little costly, like well, this render technique, the responsive skin, the structure. This is also because we think this idea of the responsive skin is not very well known here in Mexico and Latin America even. So we think like the more we use and we promote these kinds of technologies, we can like force a little bit the
Well,
use.
I wish you success in that endeavor, because I think it's an excellent attempt to bring this into the design, and hopefully you will succeed. I am aware that not just in Mexico, but also elsewhere where you have this kind of climate, a lot of new design projects. I mean, even in the desert are using the wind chimneys to bring in air and to try to use the cooling that you can get if you have the right kind of scoops for the air and so forth. But in an educational setting, which I have to admit, I mean, I love the way you have these, I guess you called them trapezoidal elements that can open to bring in the wind and so forth. But I have to express a concern of mine in that area, because within an educational environment where it's so important for people to be able to speak and hear each other easily, one of the four main factors of indoor environmental quality is the acoustical environment. And you need to be aware that when you bring in wind and when you bring in fresh air, you're bringing in noise. And I mean acoustic noise, and it makes it harder for people to hear in the classrooms, which is a really critical issue for children being able to hear what the educators want them to hear and hear each other as well. So might like to focus on that. In fact, since you didn't mention that detail in your talk, I'm quite aware that others are actually focusing on that, and there are products that try to bring in fresh air while keeping the noise out. And if you haven't been aware of that, you probably should look into some of those products. They're construction materials that are designed for that. Because of the awareness of the concern about the acoustical problems that come from having good fresh air coming in. Everybody loves fresh air, but what if you can't hear when you have the fresh air? That's a problem.
Yeah, I thank you for mentioning it. We didn't like explain it on our presentation, but the rammed earth walls also have very good acoustic acoustic conditions. So it is a very noble technique, but yeah, as you said, there are many factors that we have to consider.
Yeah, it's complex. All those factors interacting. I should probably stop dominating the question answer period, because I do see there's some hands coming up. But thank you very much for your responses. I applaud your efforts. Very good presentation.
Thank you.
Thank you very much.
Thank you.
Yes,
Peter,
there's an attendee who would like to ask a question. So Michael, please go ahead.
You need to
Looks like he's
unmute
still-
yourself.
He's
Unmute.
still muted. There you go. Now unmuted.
Yeah.
Good.
Michael, you are still muted. We can't hear you.
Sorry, I'm muted because I don't have anything to say. I don't know how my hand got raised accidentally. Sorry for
That's fine. I actually have also one more question. When William was speaking about the building companies being happy, of course, there's a lot of standards and also a lot of permits that have to be issued before something like this can actually be realized. So when that comes into the play, have you also considered the choice of the rammed earth or tapial in that certain region when in relation to getting permits and actually conforming into the building standards that are specific for that region? Has that also been considered?
Well, I don't know if you want to say something, Tere.
First you.
Okay. Well, we specifically about some norms and rules about the construction of the rammed earth, we didn't get very into that, but well, it's a system that has been used since a long time ago. So we think it's just a matter that more projects implemented, so it becomes easier for more architects and more engineers to implement it in other projects.
Yes,
Could I make a
I
comment?
just realized that that's a little bit more of an engineering question rather than an architectural question, and I'm
But
sorry
it does
about
bring
that.
It does bring up a question. If you don't mind, I'll interrupt. It brings up a question about the match between the standards, which supposedly serve a better sustainable environment, and yet I don't know if you've run into this yet, but you're going to find out sooner or later. You have to find out about the horrible mismatch between the standards themselves and what actually would benefit sustainability. The standards often are agreed by a small group of people sitting around a table, just debating and not based on too much evidence what ought to be the best practice. And so what you'll find is the best practice is something very different from what all the construction firms will choose, because the construction firms choose what will get them points and get them high numbers of green stars and highly rated for sustainability, regardless of whether those standards for measuring the way you get more and more stars actually match with true principles of sustainability that do in fact support indoor environmental quality. Acoustics, I work in the area of acoustics, so I know it very well in the area of acoustics, how poor the standards match what experts in the field would say ought to really be done. So there's a great mismatch there, and it's going to be frustrating for you when you have to face that.
Yeah.
Yet the saddest part is that those standards have to be conformed to.
Yep. Especially where there's a financial reward for it.
Yeah, exactly.
Yeah.
No, but thank you very much for your question.
Thank you.
Well, thank you for answering. I'm sorry. I probably the reason why this took a little bit longer than it should have. So if we may move on, then let's move on. So thank you again for a very interesting presentation, and we should move to the next topic, which will be bioclimatic architecture, and the presentation will be by Regina Villarreal de Bosque, Jimena Avalos Guzman, and again Valeria Valeria Cardenas Lozano, and again Ana Cristina Garcia Luna Romero. So please share your screen and begin whenever you're ready. Thank you.
Okay. We are sharing a screen now. Do you see?
Yes, we can see.
Okay, first of all, we are Valeria Cárdenas and Jimena Avalos. We are presenting the bioclimatic architecture. And we, on the table of content, we will present the pollution, first of all, how architecture damaged the environment, how architecture promotes the pollution relief. The third one, it's what is the sustainable architecture, developing the word sustainable strategy, and examples of the team. First of all, the environmental pollution, it's a very, very damaging problem that it's present in all worldwide. And this problem is present by the bad planning of the urban growth, where the industrialization grows in the city without having an order and an appropriate planning that could avoid the damage of our environment. The central activity of this problem is the architecture that doesn't represent this damage of the earth. And how architecture harms the environment, it's the climate change, and another concept, the energy consumption. First, the climate change in our planet, its cause for architecture is causes heat waves, increase of hurricanes, reduction of ice surface, coastal invasions, loss of biodiversity, and loss of drinking water. Also, energy consumption architecture has influence on the environment related to the use of heating, air conditioning, and lighting. In the last 25 years, it's present a very amount of problem, that is the sea level doubled, precipitation risk and pollution of water, the drinking water, the extreme weather events, the global temperature is increasing, the country's generation tons of carbon dioxide, and the disappearance of flora and fauna. And this is still going, and it's all around the world. Also, the energy information system of the United States is that 48 of the building has the energy consumption by sector in the United States. The 27% is the transport and 25% of industries. And like architectural strategies that we can use is to design compositional strategies to reduce risk of the environment and to be capable of contributing in our biodiversity. The pollution relief, another theme that we will talk about, is that since architecture has a great impact in pollution, a solution begin to be proposed to minimize this energy consumption of the buildings and create a positive impact in the environment. The buildings will not require much energy consumption and are designed to be renewable energies, named as the sustainable architecture. Yeah, an example of a sustainable architecture is the passive houses, that these houses does not need much electrical energy. The materials avoid the emissions of gases. They have a control of use of gas, oil, and electricity, and adequate insulation of ventilation. They also have no leaks, thermal materials, and quality windows. And there are another things that can we use for the architectural sustainability that has been in the earth, like certifications of this, that has created by the World Commission on Environment and Development, United Nations, in 1987. I don't know if I have to stop here because they're talking in the chat, or it doesn't matter.
No, please continue. I'm sorry if it distracts you. Those are mostly questions reserved for the end of the session.
Okay.
Yeah.
Okay, thank you. We have the LEED certification, that is the leadership in energy of the environment design. It was created in 1993 in the United States, and it's composed of sustainable sites, water saving, sustainable energy atmosphere, sustainable materials and resources, indoor environment quality. And another certification is the GVCE, the green. It's the Green Building Council of España, and it's a protocol that was created in 2008 at Spain, and it's only like centered to the country, but it contributes on the sustainability and the establish of criteria of their constructions. Another examples of sustainable architecture is the passive houses, the energy consumptions, and the energy information system of the United States. About the sustainable architecture, the sustainability interacts with the environment, economic, and social issues, the use of the raw materials, and renewable energies, the analysis of life cycles and materials, and the reduction of materials and uses of basic natural resources. And we have a diagram that interacts about or explains about how the architecture, the sustainable architecture is. They have solar panels, they have water circulation systems, stainless steel in facades, recycling rainwater, and energy consumption systems.
Talking about the sustainability strategy, there is an initiative of general directors of organizations that have signed the United States Global Compact, who implement the universal principles of sustainability and take action to achieve the development of sustainable foundations in cities. A global forum was formed in 1989 with business leaders elected for this work to create a global pact of values and principles to develop sustainability and to be fulfilled as such. This global compact goes hand in hand with the United Nations, and they work together to create this message to the world, which is needed to start seeing changes within human life. This forum aims to consolidate sustainability strategies and social responsibility. Can you click next? Thank you. The business people are formulating cross-cutting measures and designs that architecture can support in order to fulfill this purpose of sustainability, within which we can catalog a certain branch such as bioarchitecture. Examples of measures carried out by this firm are, for example, the generation of energy based on domestic installations that have renewable sources of energy using solar panels, as you can see in the first picture. Another measure that is promoted within this movement that fights pollution is a strategy of generating clean energy. Greater importance is being given to natural gas than its amount of carbon dioxide that it releases is a very small proportion of which is not so harmful to the environment. Another aspect that the forum mentioned is to have clean and renewable energies such as wind, hydro, and solar energy. All these concepts are based on solutions to combat this pollution that is already caused by the misuse of natural resources which are being depleted. These actions are the ones that lead to what we have been branches of sustainability implemented in architecture. One of them, as already mentioned, is bioarchitecture. We quoted, the architect Pablo Capitanelli suggests that the bioarchitecture is not only ecological and what we know how to recycle, but is to seek a healthy architecture with the best conditions for the health of people who live in the house. In terms of construction, it also has a contribution to bioarchitecture, such as the carbon footprint that a building can have. To define that a project is supported by architecture, it has to be seen backwards and forwards. The architect defines backwards how to see all these processes of the production of the materials and how the project is going to be done. He mentions that the process of how a certain material came to contribute to the project, it is fundamental to see the analysis of production and what it took to get to be used in the end of the project. The architect mentions that what he refers to ahead is to analyze all the systems that are implemented in a project to save natural resources. It is fundamental to analyze all the expenses that imply a certain project in the future. The analysis to catalog something sustainable is entire, from the beginning of the production of the material until the end of the egging of the house. A fundamental example for this concept would be a house made of clay when it comes to destroying itself instead of producing garbage or some element that is not functional. The point of this is that it produces earth in order to design something else with the material. This type of architecture seeks to implement natural materials which reject steel, aluminum, and plastic, preferring to use wood and new breathable and ecological components. Throughout history, concrete, steel, brick, and glass have been used to design large structures. These materials have left a mark on history in a negative aspect by conforming carbon fibers, and it is necessary to end this great threat. Another concept about bioarchitecture can be based on Neri Oxman. Neri Oxman is a woman who designs the relationship between building materials and the environment. What she achieves is to integrate art, design, science, and engineering into her projects with new type of materials. These materials are for, by, and with nature through the concept of bioarchitecture. Neri Oxman carried out a project called Agua Hoja in New York, from which she designed a biocompatible structure made of natural materials. Its objective is to search and find materials that replace plastic or any other material that is harmful to the environment. Neri Oxman demonstrated that there are different alternatives for building and manufacturing. She's based on the concept that these forms are based on nature, and this way one could cohabit and co-manufacture in harmony. As a conclusion of the subject of bioarchitecture, all this information will refer to an essential example in sustainable architecture, which is bioarchitecture. Bioarchitecture comes from the connection between the earth and positive energies and how they are reflected in what architecture has been. Bioarchitecture's main function is to establish relationship between what is built and developed within project with the surroundings and the environment. On this type of architecture, its constructive function is based on improving the quality of energy resources of the place and generate a positive impact for the environment. It is the ecological construction that improves the city and nature of the world, having in conscience the environmental thing. This branch of architecture is born from the bioclimatic architecture that focuses on each plot that harms the well-being of the human, for which it is decided to take actions and implement them to change the situation and cause a different sensation. Can you click next? Because there's much more information on the next, vale? Okay, so currently architects are focused on increasing the monetary value of their building, establish a predominant design in the city, and build more. However, what they should sustain is to improve the environment in which we live and create architectural features to give use to nature, weather, lightning, the movement of the sun, the prevailing winds, and may other different factors that will create a responsive skin where the building interacts with it and its environment. One study case that we researched to do our Montessori project was the Dr. Manuel Gea Gonzalez General Hospital located in Mexico City. This was designed by a German architectural firm called Elegant Embellishments, who implemented their main mission to their mission was to reconcile technology and, and, and the environment through innovative construction products. It is one of the largest in the center of the country, and what stands out is its sustainability, which eliminates the smog from the city and uses natural energy. This building is located in one of the most polluted cities in the world, which is Mexico City, and it was implemented to combat this main problem. How they solved this issue was they to do this, a new type of tile made of Prosolve 37 was used. This term is a decorative architectural model that significantly and effectively reduces air pollution in the cities. The implemented models are coated with superfine titanium dioxide, a technology that effectively combats pollution, which is activated by daylight. Likewise, this model is implemented near the main roads or highways, since this model is capable of neutralizing the pollution produced by 8,750 cars daily. It is the first building in Mexico and Latin America that has a friendly technology in its facade, I'm sorry, I don't know how it's spelled, to combat the pollution emissions caused by cars in the city. So okay, you can go.
Okay, and about the Montessori project that we do in the last semester, we start like introducing a case study of architectural skin. This study was the Lady Cilentro Children's Hospital in Bisbrain, and that we capture that the thing that we like about this certification, the vertical aluminum sheets that protect against the heat of the direct sun. And it's like it trespass the natural air conditioning and reduce the energy use.
So as we said, architects need to make buildings more green and adaptable to our surroundings. We studied a case also for our project to base it on this. It is the Lady Cilentro Children's Hospital in Brisbane that has vertical fin-like sheets that unify the exterior image of the complex. It is a double skin that protects the rear glass enclosure, becoming more or less thick or varying its inclination depending on the orientation of the visuals.
And then we do like in our like our school, our Montessori school, that was first we researched the solar incidence to put a very architectural scheme that produced the blades had this mechanism that move in the inclination depending the sun of the orientation of the sun. And it's a very interesting way to analyze the sun. And we have also a glass that reflects the properties for the better sun protection.
So in this project, we implemented this type of skin, which is capable of reducing energy demand or improved comfort in buildings. It is certainly a design element, yet it is integral to moisture protection, thermal comfort, the overall structural system, and the technical composition of a building. These thermal and visual comfort are dependent on controlling the light entering, how Valeria said and mentioned, the light entering a building through its facade. And this concept causes in our project and our school daylighting. We can measure how daylight comes within the building, thermal insulation, natural ventilation, and connection to outdoors. So based on our research, we try to grab some concepts and base them on the function of this building and what it can do to the environment. And that's, can you click next?
And also, we represent the facade with different colors that like promote different emotions to the educational system. It's like the blue. It's for the tranquility. And another types of colors depends on emotions and represents a school of and the education that we present.
So we're gonna show you some final renders and a small video so you can have the experience inside our building. As you can see, the outside part is a architectural scheme, the one that has all the colors that we based this school on all these concepts.
Yes, we wanted to do like a very vivid interior that when the students were in the interior, they present like different types of emotions with nature and all the trees we can see. And we have like many seats to have like very interactive solution. This is the central part, and we can see the stairs in this part.
Our building has three levels. Level 1 is just like the principal part, like the lobby and the main entrance. Second level is now classrooms and cafeterias and that's like the third, second, and first. No, first is the main entrance, second is classrooms and cafeteria, and third it's the same.
Yes, we divided the levels in the educational promotion of the Montessori project. It was like the kindergarten and then preschool or something in like that.
I don't know how we have time, but if not, you can like fast forward to the next level. Vale.
Yes. And that's all.
Thank you for your time.
Thank you.
Thank you.
Thank you for a wonderful presentation. Can you please share the link to the YouTube video that you showed us at the end through the chat?
Of course, I will send.
Thank you. And also, Roy, Sensei and Ana Cristina had some questions in the chat. Should we ask them now, or should we leave this for the end discussion of the session?
I think for the end will be much better. Let's finish it first.
Okay, understood. So are there questions from other attendees?
Yes, just a quick comment. Because I've noticed, and because somebody actually mentioned in the talk, the question about how to pronounce F-A-C-A-D-E. So I thought I'd just clarify what I think the pronunciation is, Canadian English. So somebody said facade, but in French it's facade, and in English I say facade. Facade, facade. Facade, it comes from French and originally from Latin, and it came into English in the mid 1600s. And now at least in Canadian English, we say facade.
Exactly like in Russian, John. So we also say facade. So
oh, okay. Okay. Yeah, I knew you'd be wondering about that as well.
Thank you.
Simply use Russian spelling, and it is safe. So just at least in this particular case.
Sometimes Russian helps to resolve everything.
Oh, yes, yes.
I think it's a pretty international word.
May I have one question as well?
Sure.
So thank you very much. Very, very beautiful presentation. And when you prepared your work, your projects, did you consider, did you learn existing prototypes, not only in Mexico, but all around the world? So what are the prototypes that you learned as good examples of such environmental integration design, responsive design? So what are the prototypes you learned?
Prototypes, what do you refer as prototypes?
Also just good examples, good projects that you may refer as a kind of in direction, kind of successful projects that you can give us as examples that you like much.
That's a good question, because actually I remember the first days investigating about this topic. We had a hard time finding first in Mexico, because there are no such projects that are good implementations with these concepts. Mm-hmm. And we find a lot like in countries like Dubai or United States, where they are more like advanced in technology, and there is where you notice what countries have other types of architecture and thinking about the future. I don't know if I'm correct to say, but like in Mexico, we find very few projects with this type, and we wanted to base on Mexico and to see something in here. So that's why we found this hospital, because that's from our country and like right from Mexico, but we have to think as a country farther for our future. But we can see in countries that are really advanced, and it's based on technology, that how do you say, it's money, because it's also it costs a lot to have this type of implementation, and it's like the project's led, or like the project that have a certain certification at the beginning, it costs a lot. So I think based on the cost and the opportunities, economically speaking, it's when they make these type of projects that are really well developed, talking in the environmental concepts.
Yes, I see. So just probably I could give you a couple of examples that I visited some time ago, and probably you may be interested just to know, because I think they have much in common in what you are doing and what you are trying to promote.
Yes.
So one is the Learning Center in the new campus of the University of Luxembourg, which is an absolutely stunning building, which was somehow integrated with a former steel plant that they had at that place. And this is also multi-level construction, where all the levels are not separated from each other, but are combined together in very sophisticated model and very, very convenient and very flexible to be used, not like a library. It is much more than a library. It is in the direction of library, but not a library at all. And another good example, so Learning Center in the new campus of the University of Luxembourg. And another one is the hospital in Metz, France, that I visited just while I've been visiting the conference, and just because of some injury, sudden. So I had to visit a hospital in Metz. And that was an absolutely impressive building, like rather an airport than a hospital, because as soon as I entered the building, I didn't have any feeling that it is a hospital. So like spacious rooms, like cafeterias all around, no doctors, just on the first floor and something. And that's a kind of also design, because the building was designed just to provide a kind of completely new idea of what a hospital is and how the hospital communicates with the society, with the patients, with everyone. So just you may have a look. They are very impressive. You will definitely like.
Thank you so much.
Thank you.
As a final suggestion, if you also like very modern architecture, look into DOC1 in Aarhus in Denmark.
Oh, yes.
That's also a very, very, very stunning library that has a theater, and also it's very unconventional inside.
Good to know. Thank you.
Thank you.
So thank you again for a presentation. Let's move on to our final presentees, who are Francisco Xavier Martinez Rodriguez, Nicolas Alfredo Bernal Ramirez, and again with help of Ana Cristina Garcia Luna Romero. And their topic is the application of biomimetics and architectural skin as a sustainable strategy. So whenever you are ready, please share your screen and begin your presentation. Thank you.
Yes, thank you. Can you see the presentation?
Yes.
Okay, good evening. We are Francisco Martinez and Nicolas Bernal, students from the University of Monterrey and currently studying our 4th year of architecture. Today, we're going to talk about the application of biomimetics and the architectural skins as a sustainable strategy and why it's important to implement these techniques in the modern construction in Mexico and around the globe. Then we're going to introduce you to a project we made last semester where we apply these concepts.
So first, when we started doing the research, the first things we ask ourselves is, why is it necessary? So in Mexico, we can see a lot of a lack of connection between nature and human beings, especially when we are talking about modern architecture. So with that in mind, we started doing a research from the past. We made a comparison, and first people started using architecture to a way to protect themselves from the environment. They use blind doors, they use windows, walls, and nowadays we do as well, but they still needed nature in order to survive. And we have lost that connection. We can see here in Mexico, some cities just as Guadalajara, that they have a lot of office buildings and apartments and houses, but at one point with all of these constructions, we started running out of space. So then people started building without any planning. We lost the complete connection that we have with nature. So we stopped caring about the pollution the actual materials provoke when a building ends their life cycle. This is some of the waste we can see here in Mexico that some of the buildings have produced. And of course, with all of that in mind, we can also see some buildings, for example, in this building, the Tower of Abu Dhabi, that has implemented some of the technologies in order to provide comfort to the people. So I think that we have to evolve as well as buildings. We don't have to, we have to start seeing architecture again as a way to connect with nature, not segregating.
Responsive skin as a sustainable design. For us to be able to design our skin, we had to define the designing guiding axis. So we started to analyze and investigate what are the responsive skins and how they respond to the environment. And after investigating, we knew that the responsive skin are the set of elements that make up the building and have a direct contact with the outside. Therefore, both the materials and the mechanisms must be considered to protect them from the climatic conditions. And to be able to make a functional skin, we think that the correct election of material is essential to avoid waste. So when the life of any building that we construct it's over, we can reuse the material of the building instead of just throwing them away and making contamination.
Another concept we wanted to implement in our design was related to bioclimatic strategies. For example, we started analyzing passive systems, and as we can see in the diagram, architecture uses site analysis to design the shape of the building in order to take advantages of the environment without the use of technology. We can have natural lighting and natural air stream without using electricity. On the other hand, we have active climate systems, which is a complete opposite of the passive systems. And instead we have central air conditioner. And well, with this type of system, we can actually, we are wasting some of the resources we have. So we wanted to implement the passive use in our design scheme.
In biomimetics, we can see from 4 different points of view. The architect can imitate the shape or the geometry, the properties of the materials, the process of the natural system, the function, and even the construction process itself, imitating the structure of patterns and generated by the same nature. Bio means life, and mimesis means imitate. So, and we have some examples. The first one is the shape, the example of shape. This is the durian fruit. It is used in the Esplanade Theater in Singapore. Next one, please. This theater used the shape of the fruit to protect the interior of itself, just like the durian protects the interior of the fruit that it's the seed. In the next example, we have the structure. This is a nest, and in the Beijing National Stadium, they used the nest for inspiration for its structure. In natural system, next one, please. We have the African termite nest. Here, the termites make current in their nest for them to maintain a regular temperature. This method is symbolized in the Eastgate Center in Zimbabwe, having a passive mechanism which gives the same result as the termites in their nest. And in the last example, we have the material properties. Here we include the algae because there's a house in Germany that's called the algae house that use the microalgae in its windows, so the building can take the characteristics and the properties of the algae, which it's the absorbing of energy, so they can later use it.
So based on what we analyze about the nature and how can it work as an inspiration for architecture, we started making a comparison between our skin, the skin we were trying to design, and some of the animal skin. We made a research about different types of animal and how they have evolved in order to survive different environmental threats. And we came to a conclusion that the crocodile skin could embody a responsive architectural scheme. It turns out a crocodile actually has two different skin. The first layer, which is the osteoderms, is more flexible and it's fragile and is composed with these bone plates. This type of bone helps the animal adapt in different temperatures. During the day, they are able to absorb the heat of the sun, and that's what basically helps them survive low temperatures in water at night. And the second skin, which is a little harder and is on top, is the scales of the animal, which only helps as self-defense. So we wanted to implement the function of the crocodile and how he uses these skins. And we made a comparison on how the second skin we wanted to design could be this hard skin, which is related to the scales of the animal, and the more fragile skin, which is on beneath the harder one, which was actually the curtain walls from the building. So we started making this comparison, and we also wanted to implement some aesthetics functions from the crocodile. So we started analyzing their patterns in the second skin, and we came to a conclusion that this could work as a model for the skin we wanted to design. So we use a pattern in the back of the animal, and here are some of the aesthetics that we applied into the model. But we also wanted to implement the capacity of the osteoderm to heat absorption, because it basically works as a solar panel. So we started researching about materials, and we found out that in Europe nowadays a cork is being used in the facades. And we also wanted to implement some of the sustainability, since we were talking about the waste some of the materials produced nowadays. So we wanted to give the skin the properties of heat absorption. And we found that the cork, besides being sustainable material, it's also resistant, it's optimal for facades. The material is 100% natural and recyclable, which help preventing the future waste, is waterproof, light, non-flammable. Well, let me just add that we wanted the model to be light because it was going to be replicated. So one of the advantages we found in the cork was that it was actually light, so we could put it in the facade, the responsive skin. And it has benefits of acoustic insulation, is resistant to pressure, compression, and it could also be used as a thermal insulator, which is actually how we related the cork with the osteoderms, because they absorb the heat.
The case of study we're going to introduce is a project we made last semester. This project is a Montessori school located in San Pedro, Nuevo León, Mexico. And in our design process, we first investigate our city and the places in need of a project with these characteristics. And we finished with a slot located, as we said, in San Pedro, Garza Garcia, and this slot has no more than 5,000 square meter surface. And this is where we started our project.
And just as a skin, we had also some design guiding axes for the building concept. And one of them was neuroarchitecture, which we actually wanted to introduce color psychology, exterior interaction, expression areas, and green interiors. We also wanted to introduce the skin that we were designing, which this provides comfort strategy, cost reduction, attractive design, and interior ventilation. And universal design, because it was clean and functional design, equal use, clarity in space. And we wanted to introduce this concept about size and space for the human comfort. So this is the base form we had to analyze what we have in the surroundings of the lot. And we found out that we have an avenue, a street, an empty lot, and a tall building on the north of the terrain. First, we wanted to make some future connections between the avenue and the streets for pedestrians. And we also wanted to leave a connection with the empty lot, because in the future, that lot could be used to design some other building, which would be which maybe could connect with what we are designing. Then we use nature as a design. We wanted to respect some of the nature that was in the place, and we also wanted to add some of the nature with big trees. So we respected the nature to create the form. And finally, we just connected the volumes in order for people to make it easier for people to transit from one volume to another.
Talking about the architectural plans that we designed in the project, we implement an open design of building, letting students and teachers travel inside the school, not only in the typical runways of a common school, but in the paths we design for making walking an experience. Separating the volumes of the project in mass, for not only having just one mass in the project, but like little compartments in it.
Let me just add that we wanted to actually have these public spaces near the street and the avenue, because in the morning it could be used as a school, but in the afternoon, where the school isn't being used, it can be used as a public space.
Yeah, and some of the areas we have in the ground level where are the library, the cafeteria, administration area of the school, and the classrooms of the school. In the first level, we continue having classrooms, the second level of the library, and a computer room. And the way that we connected this building, like we explained in the concept drawings, is with a bridge that connects classrooms with library, making an easier path to students to go there. And finally, in the last level, we have the remaining classrooms of the school, and with an art room and a teacher lounge.
So now talking about the skin on the building, we base the location. So based on the location of the terrain, we made the decision that the skin would be implemented only in some parts of the building's facade. It only needed to be where the sun was directly. So we made kind of a diagram where we predicted how the sun would penetrate the building and how ventilation could be controlled with passing through the skin. And this is how the skin looks applied on the facade. We have the architectural skin. We thought that 3-inch cork could actually be perfect in order to make it resistant. We have precast concrete as the building's wall. We have a light steel structure in order to maintain the skin in the building. And we have the curtain wall, which is behind the skin in order to protect it from the sunlight.
For our visual results, we wanted to show first of all, our landscape design, the way we connected the ground floor and the first floor with a ramp, not only because visually it's an interesting part of the project, but also because it makes an easier and accessible way to connect these levels. And there in the left, we can see the skin applied in our facade. In the next view, that it's our principal view, we wanted to show the way the sun directly hits our facade, and that's why we apply our responsive skin in all of it, taking advantage of all the things that the skin give to us. The next view it's the interior of our hangout room, which is located in the ground floor. Basically, we wanted to show how we can see the skin from the inside of the building, viewing part of the structure of the skin and the amount of light that gets through it. The reason why the windows at the sides have no skin is because they don't have directly sun. And the next view, we wanted to show a closer look to our skin of cork, including his metal structure and the way we combine the different colors of our facade to make it look clean. And that will be all. Thanks for listening and for the opportunity.
Thank you.
Thank you.
Yep. Thank you for the lovely presentation. I would first like to ask a question, then I will ask if other people want the question. The first part was very interesting about how you could relate the animal and how we were imitating the nature structures in the past. But nowadays, do you have any other examples of natural structures you think that we could use as an example to build new or design new buildings?
I don't know. I mean, I didn't quite get the question. Like, you want?
Sorry. So you mentioned a lot of examples about how fruit and animals were used for inspiration for design or architecture of new buildings. So are there any other natural structures, I don't know, animals, fruits that you had in mind, but you haven't included in the presentation?
Okay. Yes, we actually made, we talk about how we made the research about different types of animals and how they use, basically how they have evolved in order to survive the environment. We first thought about birds because we wanted to use, it was interesting to us how they created all these nests. And we had this stadium, we were presenting of how they use the structure of the nest in order to produce the facade. So we first were looking into birds, but as I mentioned before, we started seeing this protection, this second skin as a natural human or animal skin. We use our skin to protect us from the environment. So that's how we made the relation. So we started looking first into fish, but we didn't quite find a lot about fishes. Then we started looking into turtles because, well, they have these harder skin on top of around the turtle. And finally we came through the crocodile, but we didn't find quite much about the turtles, only that they had a hard skin. And as soon as we saw the crocodile, we were interested by it. So we didn't quite make that much of I don't know, like sketches about the skin with other animals.
Okay, thank you. It was just interesting of how you came to, or where you started and how you came into the crocodile. So that was the question. So I'm guessing you took the architectural skin a little bit literally, but anyway. So anybody else have a question? Okay, so I'm guessing nobody has another question, and we are also already past our time frame. So I guess we will close the session now. So thank you very much, all of the presenters and their lovely presentations. I personally have very enjoyed this morning session, and I hope that other attendees did too. So thank you again for participating and for preparing very lovely presentations, and have a lovely rest of the day or evening in your case. And if you still have the willpower and physical power to join the afternoon session, you're also welcome to that one, which the chair will be Professor Michael Cohen. And it will be an ISSM 2021, which is an international symposium on spatial media. So you are also welcome to join that. Thank you very much.
Yeah, thank you. Thank you very much. That was lovely. Fantastic.
Thank you, and congratulations to our students. You made a good work.
Yeah.
Thank you, everyone, everybody.
Thank you to you.
Thank you very much.
Thank you very much.
Thank you.
Thank you for the time.